Emmert International proudly presents the Hauling Job of the Year entry for the Specialized Carriers and Rigging Association. Emmert International, the Showley Brothers Candy Factory. A gentle move for a fragile giant. When the city of San Diego passed the funding for the construction of a new stadium for the Padres, included in the original design was a public park in the area adjacent to the stadium. A new company, San Diego Ballpark Builders, was formed to erect the stadium. As construction proceeded, they were faced with a problem. They wanted to build the park, but there was a historic structure, the Showley Brothers Candy Factory, standing in the middle of the space designated for the park. It could not be torn down, yet because of its fragile construction and age, it would be extremely difficult to move. The ballpark builders retained Emmert International to move the candy factory about 280 feet to an area adjacent to the park. Once there, it could be renovated and used for activities related to the public park and the baseball games. The challenges in moving this structure were unique and significant. 1. The candy factory, originally built in 1924 as a warehouse, is a 101-foot square, 30,000 square foot, 3-story unreinforced masonry wall-bearing structure. It has a height of approximately 45 feet, including the parapet. The total weight of the structure when moved would be about 1,500 tons, which included 603 tons of temporary support structure. 2. Since the building was a historic structure, as much of the existing brick as possible would have to be saved for the renovation scheduled to occur after the move. 3. The masonry walls were the same thickness for the entire height of the walls. 4. The upper floors are wood beam and joist floor construction, connected to interior wood post and inserted into masonry walls. 5. The mortar used in the construction was lime-based and extremely weak. 6. The parapet was very fragile and would require significant bracing to keep it intact. 7. An elevator shaft in the center of the building required the design to position the support structure and the dollies around the shaft to redistribute the weight to accommodate the shaft. 8. The structure would have to be moved up a 3% grade to reach its final destination. 9. The move would not be a straight line, but rather the building would have to be steered during the move to achieve the correct position on the new foundation. Emmert took about 24 months to develop a plan and develop engineering solutions for the challenges faced in relocating the building. The following is a step-by-step chronology of those solutions and the work that took place that allowed Emmert to successfully relocate the structure. The first step involved thoroughly cataloging the entire structure by photographing and describing it in its entirety to ensure that the historical integrity could be maintained after the move. Hundreds of photographs and room-by-room descriptions were developed, which allowed Emmert to monitor the building throughout the process. After the move, the client used the catalog to ensure the building was restored to its original state. The building had to be prepared for the move. The inside area of the first floor was demolished to make room for the support structure to be built. Non-structural exterior walls had to be removed and the bricks sorted by wall and stored for use during the renovation. The interior floor had to be leveled, some asbestos removed, and precise measurements had to be taken to record the elevation of the building at multiple locations. 2 portions of the third floor had been converted to apartments, and some of the walls and partitions had to be demolished as well. Once the areas were cleared, crews built stud walls between the floor and the roof trusses to tie the roof to the floor. Also included in the shoring was the installation of concrete blocks in each window opening, followed by the installation of an interior and exterior frame to ensure that no movement would occur in the window areas as the building was being moved. The steel frames of the windows had to be preserved for reinstallation after the move. During the demolition process, severe rainstorms occurred which saturated the ground and made work in the area extremely difficult. It normally does not rain heavily in the area, but record rainfall made exterior work and mobilization of equipment and materials extremely difficult. Work on the construction of the support structure began with the installation of 6 steel rocker beams which were W24 by 146 by 105 feet doubled. These beams provided a solid base for the support of the building and would tie the main beams to the dollies. When the rocker beams were in place, Emmert installed 42 Emmert 70-ton hydraulic dollies. These dollies supported the entire structure and support system and allowed it to move and be steered during the move to acquire the proper alignment on the slab at the new location. After the dollies were installed, Emmert crews installed main beams which were W36 by 245 by 112 feet doubled. Holes had to be cut in the north wall of the building to allow for the beams to be inserted into the building above the rocker beams. While each hole was cut, Emmert crews built support cribs and installed timber dollies for the installation process. When each hole was finished, the crews installed the 55,000-pound beams through the hole and into the building with minimal clearance on all sides. These beams were installed in 2 days. With the main beams in place, holes were cut in the east wall to allow for the installation of 24 cross steel beams, each a W24 by 146 by 109-foot steel beam. These beams had to be picked up by a crane outside the building, then inserted through the hole in the exterior wall into position on top of the main beams. This insertion required extraordinary precision to achieve the proper alignment while working within the limited space available between the top of the mains and the bottom of the second floor. Following the cross steel beams, Emmert began installation of 48 needle beams, each a W10 by 7.5 foot long, and jack tubes and other smaller support beams in the columns and in the open areas around the perimeter of the structure. The jack tubes were particularly important as they would allow for individual adjustment of the support at each column around the perimeter of the building when the building was loaded. On top of the cross steel, jack tubes, and other small steel on top of the cross steel, Emmert placed oak cribbing, oak wedges, and shimming to make full contact between the support structure and the building. At this time, the parapet bracing was installed on the roof. Crews installed a lateral brace along the entire parapet and then installed pieces to tie the brace to the roof. The support system was pressurized, and adjustments to the cribbing and shims were made to ensure that full contact existed between the support structure and the building. After the system was pressurized, the Emmert crew went through each room in the building looking for any indication that a high or low spot existed between the support structure and the building. When the support structure was complete and pressurized, one other problem existed. Emmert had to ensure that the building maintained its position on the support structure and that the corners of the support structure did not sag when the building was elevated for the move. Emmert solved this problem with the installation of a frame on top of the cross steel and around the entire structure. This steel frame with steel cables tied diagonally over the top of the roof held the building in place and ensured that the corners did not sag during the move. The building was then lifted several inches to break the seal between the building and the first floor columns and remaining exterior walls. Crews then removed the brick columns, exterior walls, and the interior wood columns for reinstallation after the building was moved. The brick was also sorted by area and preserved for reuse after the building was moved. While the demolition of the first floor support structure was taking place, crews prepared a ramp between the existing and new locations to ensure that a smooth and even pathway existed for the move. Following the grading, crews installed steel plate to further ensure an even pathway and to reduce the friction that occurs between the dolly wheels and the ground. With the demolition and ramp completed, 3 winch trucks and accompanying dead men were located past the new location. Rigging was set in place to hook the winch trucks up to the building and then the dead men. With the rigging in place, the building was ready to be moved. The ballpark builders and the city of San Diego held a ceremony to initiate the move. Following a few speeches, a bottle of chocolate milk was broken to christen the move. Right on cue, after the christening, Emmert started the building moving towards its new location. Over 3 days, the building was pulled to its new location. Once on the slab for the new foundation, Emmert had to position the building for the new support walls and installation of the existing support columns. This required an extraordinary level of precision for both the spot of the building and establishing the required elevation. Emmert crews placed the building right on the spot and within 1/100th of an inch to perfect level. When the position and elevation was achieved, Emmert had to ensure that the building did not move during the construction of the support walls and the support columns. The building was then cribbed and shimmed into place to ensure that no movement occurred during the construction scheduled to follow. When the new permanent support structure was completed, Emmert transferred the weight to the new foundation walls and the reinstalled support columns. Emmert then removed the entire temporary support structure used for the move and demobilized from the site. The following are several news clips of the move.
Through the East Village, largely because it's large, 30,000 square feet, and it's never been done before, at least on this scale with this type of structure.
It takes a combination and a lot of watchful eyes and experience to make sure that nothing happens, nothing goes wrong. It's no different than somebody at Indianapolis doing 200 and some miles an hour.
A.J. Foyt probably does this all the time. The old Showley Brothers Candy Factory, cradled in steel beams, a complex winch system very slowly pulling it to another site in another life. At this rate, it'll take a few days, the process not unlike moving a house, but more deliberate to account for the rigid masonry. Now, the building will move 280 feet up to the corner of 9th and K, roughly 80 feet a day. The building itself, part of the redevelopment around Petco Park, at its own location, construction will begin on the park at the park.
Here are some ladies packing the candy.
Roger Showley's grandfather was one of the Showley brothers. Built in 1924, the candy factory produced jelly beans, taffy, gum, and the popular Showley 5-cent Cluster Rough.
It was a candy bar covered with chocolate and peanuts. People who remember back then say it was the best thing around.
These days, the building doesn't look so delectable, prompting questions on the effort and lengths, all 280 feet of it, that are going toward preserving it.
Once it's restored, they'll probably change their tune, because it was a pretty good-looking building, and a lot of ornament on it, and it's San Diego's only candy factory.
But now with the ballpark coming, thousands of people coming for games, they're going to look across this brick building and say, what was that all about? And they'll see the name, I suppose, and start asking questions about what was that? Why do we have a candy company?
Something to make note of, kind of like 3 million pounds of brick rolling through the East Village. Matt Olson, KUSI News.
The candy factory's future use has not been determined, but some are suggesting it be turned into a candy-themed restaurant.
The downtown ballpark are also cheering another one. This time, it's a time-elapsed video. Take a look at this. It shows 3 days the builders moved this 30,000 square foot candy factory building that has been sitting there forever and ever. It was moved 280 feet. It is long considered to be an eyesore by a lot of people, and it has been relocated to make space for the new park. According to the Padres, it is the largest unreinforced brick building ever moved.
In summary, Emmert International was retained by the San Diego ballpark builders to relocate a very fragile historical structure to make way for a public space adjacent to their new baseball stadium. Emmert overcame significant technical and logistical problems to successfully complete the move. Overall dimensions: length 101 feet, width 101 feet, height 45 feet, gross weight 3 million pounds. Planning the job: 24-month permitting process, 480 hours of engineering, 1,920 hours of planning and coordination. Permits: approval from the City of San Diego, the Center City Development Corporation, and the San Diego Historical Society. Physical elements encountered: unreinforced masonry structure, building on the historic register, brick, support beams, and window frames had to be saved for reinstallation. Wood beam and joist construction connected to interior wood posts. Lime base mortar extremely fragile. Elevator shaft in center required additional support and load distribution. Structure moved up a 3% grade. Structure had to be moved at an angle to the final location. Safety considerations: high visibility, traffic, and high congestion work area. 100% compliance with site safety requirements. Radio communication between equipment operators and site personnel. Very heavy loads move through limited accessible areas. AGC and ABC and Emmert safety policies in effect. Execution: 4,740 man-hours on the job. Ingenuity and innovations. Jacking tubes were used to individually load each column and pre-stress the steel grillage frame. Large rollers assisted installation of 109-foot beams through holes in the wall and into place inside the structure. Wall bracing used to keep building in the center of the support structure and to keep the corners of the support structure in line. Building support steel was checked using finite element analysis to check deflection. Loss prevention: no accidents, no injuries, no property damage, no loss of time, no structural damage, no cargo damage. Schedule: on schedule and within budget. Contract: lump sum, firm fixed price.